Quick, graph one period of y equals 3 times the cosine of the quantity 1/2 x plus pi over 3 plus 2 by hand. This is part of the family of functions series. You will need paper and a straight edge, or you can download this PDF. Press pause as needed anytime during the video. Notice again you're only asked to graph one period of this one. So we're going to start off by analyzing this. Which parameters affect y values? We'll look at those first. In this case there are two of them, times 3 and plus 2. 3 times multiply each y by 3, plus 2 add 2 to each y value. Now which one do you do first? Well, by the order of operations, we multiply first, add second. So let's look at the y values of the points of interest. 3 times the y value plus 2. The maximum normally is at y equals 1. We have to multiply that by 3 and add 2. So the maximum is going to be at y equals 5. Points of inflection are normally along the line y equals 0. But again, we multiply 3 times that 0 and add 2, and we get y equals 2. The minimum value is normally at y equals -1. We multiply that by 3, -3, add 2, and get -1. So the minimum still stays at y equals -1. Here's a quick summary over on the side below. Those are where the values came from. Which parameters affect the x values? That's these two. Beginning of a period normally starts at x equals 0. What we want to do is set the argument equal to 0 and solve for x to see where this one starts. So the argument is the quantity 1/2 x plus pi over 3. Set it equal to 0. Solve for x. Pause is needed. I'm going to multiply each side by 6. When I distribute that on the left, I get 3x plus 2 pi equals 0 on the right. Subtract 2 pi and divide both sides by 3. So our graph is going to start at an x value of -2/3 pi. The end of the period normally ends at x equals 2 pi. So again, we set that argument equal to 2 pi and solve for x. Pause is needed. First of all, I'm going to multiply each side by 6 again to clear out all the fractions. And we get 3x plus 2 pi equals 12 pi. Subtract 2 pi from each side and divide both sides by 3. And so the period ends at 10 pi over 3, when x is 10 pi over 3. Using all the values below, decide how to mark units on the axes. Pause is needed. We suggest marking every pi over 3 on the x-axis and having y go from -2 to +6 because of our max and min values. Pause to do that. So this is what we prefer the axes would look like. Pi over 3, every pi over 3 is marked off. And from y equals 6 to y equals -2 is marked off. Now let's all put all this together. With this quick summary, this tells us where the points are going to be. I'm going to draw dotted horizontal lines at the maximum, point of inflection, and minimum. These are not asymptotes, they're just boundary lines to help me graph it more easily. So at y equals 5, I did that one in blue, y equals 2 in orange, and y equals -1 in that aquamarine color. So recall the graph of y equals cosine x. We'll look at the 5 points of interest, starting with cosine starts at the beginning of a period and a maximum. Well, for this one, the beginning of the period is at -2 pi over 3 for x, and the y coordinate is 5. So this point maps to negative 2/3 pi over 3, comma 5, right there. We'll then look at the end of a period, which is at normally 2 pi max 1. But for us, the period ends at 10 pi over 3, and the max again is 5. So we'll go ahead and plot that point, 10/3 pi, comma 5. Halfway between those two max points is a min, normally at pi negative 1, the min. So we need to go halfway between these 2 points right here. And that turns out to be at 4 pi over 3. And then the minimum is still at negative 1. So 4/3 pi, negative 1. And you can see that kind of makes a V, looks like halfway between. Between the max and min is a point of inflection. So halfway between here is going to be at pi over 3, and the min is at, the point of inflection is at y equals 2. So pi over 3, comma 2. And again, you can see that's midway between those 2 points. And the last midway point between the min and then the max is going to be at 7 pi over 3, 2, where the points of inflection are. And that's right here. And again, you can see that's halfway. Pause is needed. We're going to connect the points as a cosine wave, beginning at the max and drawing half of a frown down, concave down, then a whole smile, concave up, and half of a frown, concave down. And this is what it looks like. It's a beautiful cosine wave. Now just to check, let's look at the equivalent form, how we can factor out the half inside the argument. And notice that that means this is a phase shift left 2 pi over 3. And we can see that's exactly what happened. We started at a max, negative 2 pi over 3, max. Also, the period's affected by this coefficient of x inversely. So we'll take 2 pi times the reciprocal of a half, and so that will be 4 pi, and that's the period. And from negative 2/3 pi to positive 10/3 pi is 12/3 pi, which is 4 pi. So all checks. Now you try one, and this is going to take a while, so you're going to have to pause for quite a long time. But just graph one period of this equation. Hint, again, you're going to need to change the units. Pause for a while, resume when you're ready. So this is the graph we got. I showed where the max, point of inflection, and minimums, where the y values are, the beginning of the period, the end of the period, and then I labeled these in color so that you could see where your key points of interest need to be. Pause is needed.